tutorial 5 out of 6. We're going to be looking at getting an equation, the y equals mx+c equation, from the graph. So if we look at this graph here, we can see that it cuts through the y-axis here at 3. So our y-intercept is equal to 3. Now the other thing we need for our equation, remembering our equation is y equals mx plus c. So we've got the c, the m, that's the gradient. So remember, gradient is equal to rise over run. So if we look at this point here, and it cuts through nicely again at this point here, it's nicely drawn in a green dot there. So to go from this point to this point, working left to right, just like we read a book, we go rise down 2. Now remember, down is negative, down 2. And then we run 1, 2, 3 across. So we've got a gradient, it's a negative gradient because the line is going downhill, negative 2 over 3. So to write our equation, we've got y is equal to m x plus c plus 3, y-intercept, gradient, down 2 across 3, down 2 across 3. Okay, so let's look at another one. Let's look at uphill, a positive gradient. So for our y equals mx plus c, the m equals and the c equals. C is the easiest one to find first. There it is right there, cutting at negative 2. The gradient from there, and it's nicely again dotted in where it cuts nicely on the crisscrosses. Okay, so we go up 2, cross 1, rise 2, run 1, rise 2, run 1. We don't have to put over 1, remember. 2 divided by 1 is just 2. So we can write our equation, y equals mx plus c minus c in this case. Okay, this other one's got 2 slight differences. It gets quite a bit more difficult here for 2 reasons. The first reason is it's cutting here at 0. Well, it's not so difficult. It's cutting the y-axis at 0. Well, straight away, the y-intercept is 0. So that wasn't so difficult after all. But here's the tricky part. All our other graphs went up in ones. 1, 2, 3, 4, 5, and across 1, 2, 3. But this one's not. It's going 2.5, 5, 7.5, 10. So not very nice, even steps for our squares. But there's no change really. So the other thing is it hasn't got the dots drawn on for us where it cuts nicely. Now it cuts nicely. Use a red pen. Cuts nicely here and at every single diagonal. But of course it's not up 1, run 1 like in previous graphs we've looked at. So let's look at what it is. So our m is equal to rise over run. So working left to right, we rise, that's 50, that's 150. Okay, so we rise 50 and we run, well, that's 2.5. Well, that's not very nice looking, is it? Rise 50, run 2.5. We've got a fraction and a fraction, and that's not very nice at all. So I'm going to try something different. I'm going to go to from the first dot to the third dot and see what happens. So this time I'm going to rise 100 and run 5. 100 over 5. Now that looks a lot better. Now can I simplify that? 100 divided by 5. Yes, I can. That's 20. So my m is equal to 20. So to write the equation for this, y equals 20x plus our y-intercept is 0. Do we need to say plus 0? No, we don't. We can just say y is equal to 20x. So every one across, it goes up 20. Another one across, it goes up 20. So it goes up 20 for every 1 kg. So what's on this axis? The price. The price is going up $20 per kilogram. So we could perhaps use different numbers instead of x and y. This is normally the x-axis, but it's actually w this time. So we could go 20w. And instead of the y-axis, it's actually price or cost. So where you go, the price is equal to 20W. The price is equal to 20 times the weight in kgs. Okay, so that's the end of this tutorial on finding an equation from a graph. We've got one more tutorial in this set of 6, and that's going to be solving an equation for x or for y using that same equation, y equals mx plus c. Have a look at the video and you'll understand better.